Okay, we'll look at some of the homework problems that are in section 7.3. In problem number 1, you're asked to find the decimal representation of 1/3. In this case here, you can do long division if you like. I'm going to do 3 divided by into 1. And to do that, I have to place the decimal point behind the 1 and the decimal point in the quotient and add a 0 behind the decimal point. That way I can divide 3 into 10. That's going to go 3 times. And 3 times 3 is 9. With a remainder of 1, add another 0 and bring it down. Do 3 into 10. Again, that's going to go 3 times. 3 times 3 is 9, with 1 left over. So you can see here that I'm getting a remainder of 1. And if I keep adding zeros, the 3 is going to repeat. So in this case here, 1/3 as a decimal will be 0.3 with a bar on top, indicating that the 3 repeats. So here it would be 0.3 with a bar on top. All right, number 2, you're going to convert the repeating decimal to a over b form where a and b are integers and b is not equal to 0. In this case here, you got 2.63 and the bars on top of the 6 and the 3 showing that those 2 digits repeat. And I want to write that in the form a over b. Here's what I'm going to do. I'm going to let n be that repeating part, that decimal, 2.63 repeating. Now, there are 2 numbers that repeat. So what I'm going to do here is multiply this equation, multiply both sides of this equation by 100. Why 100? Because in this decimal, only 2 digits repeat. So that's why I'm using 100. So it'll be 100n. That's going to be equal to 263.63 repeating. When I multiply by 100, I'm moving the decimal point 2 places to the right, so it'll be 2.6363, and the 63 has the bar on the top, showing that it repeats. It's still a repeating decimal. Now what I'm going to do here is subtract those 2 equations. When I subtract, 100n minus 1n is 99n. Now when I subtract the right-hand side, the 63, which is the repeating part, that goes. So now I'm left with 263 minus 2, which is 261. So now I have 99 over 261. Divide both sides by 99. You'll get n is equal to 261 over 99. Now in this case here, I'm going to reduce that in simplest form. Here in this case, I'm going to divide the numerator and the denominator by 9, because I know the denominator is going to be 11. Now if I divide 261 by 9, that's going to give me 29 over 11. I can do this on the side here if I want to. That'd be 218, 81. Yep, 29 over 11. And we're going to leave this as an improper fraction because we want to write that in the form of a over b. So in this case here, 2.63 with the 63 repeating as a improper fraction in the form of a over b would be 29 over 11. Okay, problem number 3 is to order from least to greatest. And you have these numbers here. What I'm going to do here is, let's see here, I'm going to go ahead and write out 1.787, repeating as 1.778787, repeating. That's this first decimal right here, because the 7, 8, and the 7 repeat. And then negative 1.788787, and then repeat. I'm trying to have the same number of decimal places here in this case here. because the 8 and the 7 repeats. And then in this number, only the 7 repeats. So 1.7877777 dot dot dot. And then negative 1.787. Now I'm going to put zeros there because here this is a terminating decimal. Now what I want to do here is compare each place value position one at a time. Now in this case here, the 1s are the same. In the tens place, the 7s are all the same. In the hundreds place, the 8s are all the same. In the thousands place, the 7s are the same. But notice when we get to the 10,000s place, the numbers are different. Okay? So here, I'm going to start with the smallest number because here we're dealing with negative numbers here. Okay? So the smallest number will be the number that is close to 0. In this case, the 0 is the smallest. So here, negative 1.787 is the number that's the greatest because that number is closest to 0. And then here, these two, I'm going to have to compare those a little bit more. The first number and the third number, I'm going to have to compare those two. So in this case here, it will be this number right here, 1.787 repeating. That will be the next number. And then negative 1.787 with a bar on top that repeats. That will be the next number. And then the last one will be negative 1.78. Well, the 8 and the 7, well, just the 8 and the 7 repeats. So in this case, to answer that question, it will be answer B. So in this case, you might have to expand each one of those and then compare each place value position to see which one goes first. And of course, the lowest number, since we're dealing with negative numbers, the lowest number is going to be the number that goes first because that number will be closer to 0. Okay, problem number 4. Here we want to find a rational number between 3/4 and 0.75 repeating. Well, I know 3/4 as a decimal will be 0.75. That's what 3/4 is. And then 0.75 repeating, well, 0.75, and so on. Because we know the 7 and the 5 repeats. Alright, in this case here, if I find a number that's going to be between those two, and if I put zeros here, it could not be D, it can't be C, it can't be B. It will have to be A. 0.7527. That's the rational number that's between 3/4 and 0.75 repeating. Alright, number 5. Use the fact that 0.1 repeating is equal to 1/9 to mentally convert each of the following into fractions. Like in this case here, 0.3 repeating. I'm going to use a fact here, I'm going to use a 3 here, and I know that 0.1 repeating is 1/9. So 3 times 1/9 would be 3/9. Or, in simplest form, 1/3. So 0.3 repeating would be 1/3. And then 3.7 repeating, using the fact that 0.1 repeating is going to be 1/9, I can say this. Let's say the 3 and the 7 well, let's say here 3 plus, and then that 7 will be multiplied by 1/9. So here, this will be 3 plus, 7 times 1/9, of course, will be 7/9. So that would be 3 and 7/9. And they do want that as a mixed number. So here, 3.7, repeating, is 3 and 7/9. All right, number 6. We're going to use the fact that 0.01 repeating is 1 over 99 and 0.001 repeating is 1 over 999 to mentally convert each of the following into fractions, like 0.19 repeating. So here there are 2 digits repeating, so we need to use the fact that 0.01 repeating is 1 over 99. So here, this will be 19 times 1 over 99, which would be 19 over 99. And I don't think that this can be reduced because I know 19 is a prime number. So in this case here, 19 over 99 would be the fraction for 0.19 repeating. And part B, 6.576, where the 5, 7, and the 6 repeat. Here, I can bring over the 6, and then I'm going to add to it the 576, and notice that 3 numbers repeat, so I need to use the fact that 0.001 repeating is 1 over 999. So 576 will be over 999. So this will be 6 and 576 over 999. Now we do need to simplify the 576 over 999. And I think we can use 9. We'll start off with that because I think here 9 can go into 576. Uh, 64 times. So here, this will be 64. And if I divide 9 into 999, that'll be 111. So this will be 6 and 64 over 111. But it needs to be done as a improper fraction. So if I do 111 times 6, that's 666 plus 64, which will be 730 over 111. Okay. Because they wanted as a simplified fraction, so it has to be as a improper fraction, 730 over 111. Okay, so this should be enough to assist you with some of the problems that are on the MyMathLab homework.